and we're back to Haskell. Yesterday we learned a little bit about lists in Haskell and writing functions. Not really a lot. There was like a long list of things you can do on lists. Yeah, manipulating, we can check for the maximum, the sum of the list, the product of the list. We can drop a couple of numbers and just, yeah, we can drop the 3 first numbers and get the rest. Yeah, so a lot of things to do with lists. Manipulation of lists. And they said a general way of working is that you, in Haskell or functional programming, something I remember from yesterday was that you do a lot of simple functions like this. This is a double me, that's a simple function. Then if you want to double 2 numbers, right? You have a simple function double me and then you double us, right? If you want to double both of these. Yeah. So that's how you increase complexity. You start with as easy functions as possible and then build complexity with the functions instead of having too complicated functions. And we learned a little bit about syntax, whitespace and whatnot. Oh right, Colgate in on tap reminds us that making the... Oh shit. You got to be in insert mode. Right, making a list like this is just a fancy way of saying... Alright, what was it like? This, yeah. Right. Because everything is a function, right, in functional programming. So we don't... yeah. A list is just a function that creates a list. Yeah. This is just a syntactic sugar, I think we call that, to visualize a list. What actually happens is that we have this function, right? And this infix function takes the one thing on the left and puts it in the list to the right. Kinda. So we put the 5 in here and it prepends. Yeah. So we put the 5 in and then we put the 4 in and then we put the 3 in and we put the 2 in. So we repeat this function 3 times. Well, shit, no, I missed one. We have to put it into the list, yeah. This is an empty list. So these are the same, right? They are equivalent, I think. They have the same result, but... No, this is probably a data type, a finished data type, and this is a function. Because this is a list. A list is a thing. We'll get to it. Thanks for reminding me, Colgate on top. I forgot about that. Now we're looking for ranges. What if we want a list... Oh shit, let me do like this. What if we want a list of all numbers between 1 and 20? Sure, we could just type them all out, but obviously that's not a solution for a gentleman who demand excellence from their programming languages. Indeed. Instead, we will use ranges. Ranges are a way of making lists that are arithmetic sequences of elements that can be enumerated. Programming has this thing, right, where it's a fairly easy concept, but the language here is just, what the fuck is going on? Right? Ranges are a way of making lists that are arithmetic sequences of elements that can be enumerated. It's a range, right? This is what happens. 1 to 20, we want all of them, right? And that's what we get, 1 to 20. Putting that with these fancy words, oof. Numbers can be enumerated, 1, 2, 3, 4, etc. Characters can also be enumerated. The alphabet is an enumeration of characters from A to Z. Names cannot be enumerated. What comes after John? I don't know. Wait. I mean, in Haskell they can be, right? Because you can have a list of a list. And John is a list. So you could enumerate it and get the letters in alphabetical order. Or you could sort the names with the first letter, right? With the head. With the Haskell head, you could sort them alphabetically. But I guess what they point out, that names can't be enumerated. It's not the names, it's the characters that gets enumerated to the text's point, isn't it? Yeah. To make a list containing all the natural numbers from 1 to 20, you just write 1.2. That is the equivalence of writing. Boom. All right, so just double checking. Since we know that letters can be enumerated, and this is an infix function, A to G. Wait, why not? Oh, right. There we go. I forgot to make it into a character. Colgate InnoTab says you'll need to implement enumeration for it first. Yeah, exactly. I mean, you could do it. You could enumerate the names yourself, but that would be, right? How would you implement it? Right? Any way you would implement it would be a number or a letter, a number or a character. So the names themselves will not be enumerated. You could, like, the names can represent a person, and you can take their age and sort them, enumerate them by age, or the first letter in their name, right? But it's still a character or a number then. The name itself, right? How would you enumerate that? You could probably make some sort of rule, but I kind of feel that any rule, just instinctually, I think that any rule you could figure out would be either a character or a number. Right, to make a list containing all the natural numbers from 1 to 20, you just write 1 to 20. I don't know what this is called, yeah. It is the equivalent of writing all of this, and there is no difference between writing one or the other, except that writing out long enumeration sequences manually is stupid. Alright, do we have like a start, stop, step thing? Can we... Oh, right, they actually did it down here as well. Right, what if I only want even numbers? Oh, I would just write a function. Right, that's the Haskell way of doing things. I write a function that returns the even numbers, right? It multiplies. Yeah. Double me. Here we have. This is how we make even numbers, right? And then we just do it from 1 to 10. Then we'll get 2. Alright, so what about doing it this way? Alright, so we make a list that we go from 1 to 10. But we do double me 1 to 10. Is this gonna work? I don't think so. Yeah. We would need to somehow implement it double me for each item in the list, which I don't remember how to do. There are easier ways in Haskell. They come soon enough in the book. Yeah, but you could do it yourself somewhere like this, but it's already implemented. You would just have to somehow implement the function for each number in the list, right? Double me doesn't take a list. Yeah, that doesn't work. Double me takes a number, not a list. All right, ranges are cool because you can also specify a step. Yeah, that's that's super easy. Yeah, that's super easy. Colgate in a tap, indeed. Ranges are cool because you can also specify a step. What if we want all even numbers between 1 and 20, or every third number between 1 and 20? Yeah, 2, 4, 2, 20. Yeah, you just show how to do it. What about A, C into what, like K, whatever. Yeah. Yeah, it just does it by numbered. Yeah. Right. It is simply a matter of separating the first two elements with a comma and then specifying what the upper limit is. While pretty smart, ranges with steps aren't as smart as some people expect them to be. You can't do 1, 2, 4, 8, 16, 100, no, and expect to get all the powers of 2. Yeah, that would... I did not expect that to work, no. Firstly, because you can only specify one step, and secondly, because some sequences that aren't arithmetic are ambiguous if given only by a few of their first terms. Indeed. To make a list with all the numbers from 20 to 1, you can't just do 20 to 1. You have to do 2019. Yeah, exactly, because the normal way, right? This function takes a plus, right? It adds 1. It uses suck, doesn't it? Yeah. Right. 111.20 is right. It uses the suck function. And if you want to do it like a reverse suck, I don't remember what that was, but the predecessor, right? Yeah. That's my favorite function so far. The suck. Yeah. This is not the predecessor. This is a reverse suck. Yeah, there we go. Reverse suck. That's the name of this function. All right. Watch out when using floating point numbers in ranges, because they are not completely precise by definition. Their use in ranges can yield some pretty funky results. Can they? Oh yeah. Wait. Funky indeed. Because they are not precise. 0.1, 0.3, 0.5, 0.7, 0.89999, 0.1.09999. Right, that fucks up. But it should be fine if we do just 0.1. No, 0.2. 0.4 to 1. That should be working fine. No, it did not. My advice is not to use them in list ranges. Yeah, that makes a lot of sense. Right? Where do you make your rounding? I mean, decide how many... What are these called in English? Decimals? Did I just swinglish that? Decimals is what we call them in Swedish, I think. How far back you go? Precision. Yeah, how precise should you be? Should we stop here or here? One would guess, one way of doing that would be, right, since we only used one decimal, they could have stuck with one decimal, right, and rounded, never adding anything extra. What rounding rule would you use? I guess, yeah, problematic, I guess. You can also use ranges to make infinite lists by just not specifying an upper limit. Nice. Later, we'll go into more detail on infinite lists. Oh man, infinite lists, that makes me happy, yeah. For now, let's examine how you would get the first 24 multiples of 13. Sure, you can do 13, 26, and then... Oh, nice. 24 times 13. I love that. There's a better way. Take 24. Oh, right. So by saying take 24, we create... Yeah. This is a function that takes the 24 first items of a list. So if we have an infinite list here, since we only take 24, that's an easy way to do it. Oh man, infinite lists are great. Yeah, take was yesterday, indeed. Like all of the things we could do with the lists was yesterday. Yeah, and we take the 24 first elements. That was take. Yeah, because Haskell is lazy, it won't try to evaluate the infinite list immediately, because it would never finish. Yeah, it'll wait to see what you want to get out of that infinite list. And here it sees you just want the 24 first elements, and it gladly obliges. That's kind of cool. However, isn't... Right, if we're thinking about optimizations here, isn't this more optimized? No. No, it's not. Because this here... Well, it depends on which of the functions are more optimized, multiplication or take. Isn't Haskell cool? It is cool. Yeah, it is cool. Alright, a handful of functions that produce infinite lists. Alright. Cycle takes a list and cycles it into an infinite list. Nice. If you just try to display the result, it will go on forever, so you have to slice it off somewhere. Right, slice it off. That's, yeah, take. Lol 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 lol. Trollololololololol. Right, repeat takes an element and produces an infinite list of just that element. It's like cycling a list when with only one element. Why would you want to do that? Oh man. My memory is terrible. I was gonna do the shining thing. Yeah, I was gonna do the shining thing. When he types it out. It sits at the typewriter. I don't remember what he types, but he would be super happy with having this. Yeah, he would be super happy having a Haskell, because it would just be done, right? Yeah. GHCI probably gives an error if you just cycle. Oh, I think GHCI would probably give an error if we just do any of the infinite things, right? Because GHCI tries to print. And trying to print something infinite, that I hope it throws an error. Do we try it? Let's try it. It did not throw an error. Ah. It just went on ahead. I instantly heard my fan start spinning. Yeah. It just instantly my fan started spinning. Whoa, 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 what's going on? My CPU did not like that. Although it's simpler to just replicate. It's simpler to just use the replicate function if you want some number of the same element in a list. Right. Replicate 310 turns. Ooh, that bothers me. What about... No. Wasn't this? Yeah. No, it makes sense. I was kind of thinking that I wanted to flip the numbers, but no. It's like we were talking about yesterday, right? How you type in math. You type 3x, not x3. So we type 310, not 103. Melanol the Destroyer says, I'm back and I kind of regret trying Enderall. Wait, did you not enjoy yourself or do you feel bad? Well, at least the itching is over. Nice. And guess who's back to banging the handrails? Oh no, that's unfortunate. Unfortunate indeed. Did you not enjoy the game or do you feel guilty for doing it, right? I mean, you did a good job. You managed more than 1 week, right? And then, yeah, next time maybe you'll do it 2 weeks if you decide to try again. Or continue the experiment of not playing any video games. Oh no, Colgate in on tap says math is in the next chapter. Oh no, maths. I'm a list comprehension. Alright, we learned some more about lists, right? What did we learn? Oh, ranges. Yeah, creating... Not typing out lists manually, but creating lists and infinite lists. Nice. Now we're moving on to list comprehensions. Oh yes. Just a little bit though. Yeah, just a tiny amount. All right. If you've ever taken a course in mathematics, I haven't, you've probably run into set comprehensions. I've never run into set comprehensions. I'm assuming that they assume that I haven't. Melanol the Destroyer says both. There's too much. Explore every corner in Enderall. Wait. Explore every corner with a skill you have to constantly use to see collectible things that you won't see otherwise. Oh, that sounds annoying. Yeah. Well, Gitinotab says I have. Oh, I know indeed. Maybe when I'm back to loving fiction. Yeah, that Enderall, that's what it looks to me, right? It's a narrative experience. Banana Wolfmonk says that sounds like Metroid a bit. Wait, do you have... Man, I don't remember that. The only Metroid I've played was the one that came out for Wii. Man, I love that game. I tried to get my hands on a Wii and that game, but my ex from that time kept the Wii. Such a bitch move. It was. Didn't think about it later. Until much later. Because she kept the Wii and all the games because she purchased the Wii. But I purchased all the games, so I had spent more money than her. Like, overall, but I didn't think about that. I was just depressed by being dumped shit back then. Yeah, that sucked. Alright. On the other hand, she did buy the Wii, so... Melon the Destroyers. Wait, you mean you're not a virgin, Kappa? Such a shame. Wait, why is that a shame? I'm no virgin. Might as well have be though. Haven't had sex in years. Years, I tell you. Been forever. Alright. If you've ever taken a course in mathematics, you probably have run into set comprehensions. Colgate didn't have, yeah. They are normally used for building more specific sets of general sets. A basic comprehension for a set that contains the first 10 even natural numbers is... Boom. Okay, so a set. Wait, a basic comprehension for a set that contains the first 10 even natural numbers. Oh yeah, so it's what we did before. 2, 4, up to 20. Yeah. Melanol the Destroyer says, same. I wish I stayed a virgin. Wait, what? Why? It also made my life a lot more painful. Blah. I like having new experiences. I don't regret that at all. Yeah. Holy shit. As a teenager, was sex such a blowed up thing? Oh, I gotta have sex, it's gotta be amazing, it's gotta be amazing. Like, fucking teenagers. I think if I for some reason stayed a virgin, that would just mess me up a little bit, yeah. Wait. Colgate on tab says, this set contains the first 11... even natural numbers though. Oh, it contains the 11? Did he mess things up? Right. 2 times x. X, I don't know what this is. I don't know what this is. Oh, this is a natural number though, yeah. And x is smaller than or equal to 10. Right. So we have... Wait. Do we start with 0? Do we start with 0 here? The first x is 0, so we get 0, then we get 2. And then... Oh, yeah. Right, that becomes 11, right? That becomes up to 0, up to... Well, it depends, right? If you start on 1, this becomes 0 to 20, yeah. Oh, Melanol the Destroyer says that 0 is not a natural number. Banana Waffle Monkey says it's been 3 years for me, give or take, if you don't count oral. Fucking pandemic. Wait, did you fuck the pandemic? You did not fuck during the pandemic, Banana Waffle Monkey. Wait, weren't you at a rave like the other day? And you've been out quite a bit recently, haven't you? Isn't it like, aren't you up and running? I got fucked by the pandemic. Alright. So then it hasn't been 3 years. Yeah. Melanol the Destroyer says, super sad, sorry. I locked it up deep in my head. Oh, right. Right. That's not necessarily about your virginity, right? It's about... Yeah, you had a super... You wish you had lost your virginity in some other way than the way you did. I get it now, yeah. Same with negatives. Negatives plus 0 plus positives. Whole numbers. Natural are for counting existing apples. Oh, so it is.
Take a deep breath, Hardigan. Settle down and think straight.
Banana Waffle Monkey says, I've pulled the digits a few times, but get ghosted eventually. Oh, that's unfortunate. Also surprising. I mean... You're one of the smoothest persons I've had the pleasure of reading texts of. Yeah. Super smooth. Colgate Tab says 0 is the most of the time a natural number. Some sources exclude it from natural numbers. All right, so in this example, we say that, of course, since he said the first 10, he will exclude 0. Yeah. That's a generous interpretation of what he's doing. He excluded 0. So he started at 1 up to 10. So that becomes the 10. What does this euro sign mean, by the way? And the pipe symbol. I don't know. Does it matter? Include. Oh, include natural numbers. All right. X has to include natural numbers. Is that what this bit says? Yeah, X belongs to natural numbers. There we go. Melanol the Destroyer says, no, I wished I stayed a virgin forever. I liked it. Well, I mean, a lot of people do that. They re-virginize, right? Why not just say, oh, I'm gonna be a virgin for the rest of my life? Or a eunuch. Is that? No, that's not it. Eunuch is someone who's got it chopped off, right? No, but you can decide to never have sex again, right? You can make that decision if you like. Or not today, I guess. Is element off? Is that the pipe symbol? 2 multiplied by x is an element of x. Wait. Oh, it's the other way around. X is a natural number and it's element of. Very confusing. It's just a separator. Oh, so these are the 2 rules. Yeah, I know that it says 2, 4, 6, 8 up to 20. That part. I was just curious about the math notation because I don't know math notation. Right. The part before the pipe. Yeah. The part before the pipe is called the output function. X is the variable, n is the input set, and x is smaller or equal to 10 is the predicate. That means that the set contains the doubles of all natural numbers that satisfy the predicate. Yeah, exactly. If we wanted to write that in Haskell, we could do something like take 10 to 4 ... Yeah. But what if we didn't want doubles of the first 10 natural numbers, but some kind of more complex function applied on them? Yes, indeed, we want that. We could use a list comprehension for that. Hopefully it'll be similar. I've done a little bit of list comprehension in Python, so hopefully that'll help me out. But I get very confused by it. List comprehensions are very similar to set comprehensions. We'll stick to getting the first 10 even numbers for now. Thank you. The list comprehension we could use is... Right, and that is it. Alright. Right, so each element in the list is x multiplied by 2. Right, in Python this would be 4. Yeah, they would write it 4. And then for all this stuff. Wait, what does this mean? Oh, x. Right, that's what I tried to do before. Let's write this out. All right. The first bit is easy, right? That is what we do with every x. And then we decide what x is. X is, right? I'm assuming that this icon means that we kind of push this into x, kind of. That makes sense to me, right? It's an arrow thing, right? We take every element of this list and use it as an x. So I assume this is the syntax of, like, basic syntax of list comprehension. right? Here is what you do with your x, and here is where you define what your x is. Banana Waffle Monkey says, my hair does most of the talking for me when I go out. Nice. Makes things easier because people approach me and I tend to be more socially reactive than proactive too. Oh, we have that in common, yeah. Except when I go out, I try to stay the fuck away from people and try not to be approached. Yeah. I just hide in the corner. Leave me alone. It doesn't even... Oh shit, it doesn't even have to be a list? I don't think so. Oh, it has to be a list. Right, this thing, this function, whatever it's called, takes a list, probably. It's an infix function. Yeah, exactly. Alright, this was fairly easy, right? The structure. Like the pipe in the middle. X is drawn from the list 1 to 10, yeah, and for every element in... Yeah, we bound X, that we get an element. Yeah, it's doubled. Here's a comprehension in action. Yeah, we tried it out, it works fine. As you can see, we get the desired results. Now let's add a condition or a predicate to the comprehension. Predicates go after the binding parts and are separated from them by a comma. Okay, let's say that we want only the elements which doubled are greater than or equal to 12. Oh shit. Why are you doing it this way? Wait, where is it? This is the one we did, right? And then we do a comma separation here. Yeah. This is a predicate. This is kind of an if statement, right? Yeah. Yeah, right. I think Python has pretty much taken these list comprehensions and pretty much translated them into Python, the Python way of doing things. Right, Python would say x times 2 for x, and then they would have like a description again. I don't remember exactly the syntax, but they would do the same, right? Some kind of what's it called? Some kind of function here. Yeah, some kind of function that gives us different x depending on what it is. Yeah. And then last, there are some if statements. If x times 2 is greater than or equal to 12. Yep. So the Python, going through it in Python actually did help. Because Python just took this straight off. It kind of looks like. Yeah. Cool, it works. How about if we wanted all numbers from 50 to 100, whose remainder when divided with the number 7 is 3? Easy. Right. X, we take all the numbers between 50 and 100, yeah, and then we... Yeah, when the... What is this called? The remainder is 3. Yeah. It's definitely like an if statement here. You could use the word if before here if you wanted to. Modulo. Wait, I don't know how to pronounce that. Modulo? Oh yeah, modulo. That's division, but with natural numbers, whole numbers. It's division with whole numbers and remainders. That's when I first learned division. You learned that before you learned decimals, so you only learned modulo. Success. Note that by weeding out lists by predicates is also called filtering. Right. Could probably do that 2 ways, couldn't you? Right, because this one, right? We're talking about lazy languages. This function iterates over. This function iterates 50 times, right? No, it doesn't. It's a lazy language, so we kind of have to ask for a specific... Yeah, but no, if we ask for this list, right, then it iterates 50 times, like it is done. If we want to get this whole list, it iterates 50 times. Which is not super lazy. It kind of feels like the list comprehensions are not super lazy. Success. Note that weeding out... yeah, it's called filtering. We took a list of numbers and then we filtered them by the predicate. Now for another example. Let's say we want a comprehension that replaces each odd number greater than 10 with bang. And each odd number that is less than 10 with boom. Right. If a number isn't odd, we throw it out of our list. For convenience, we'll put that comprehension inside a function so we can easily reuse it. Boom bangs. Wait. Boom bam. Excess. Right. Why do we have an if here? If x is... So confused. Let's type it out. Boom bangs. Excess. I'm assuming this is a number. It's a function. All right. And that we create like this. If x is smaller than 10, then boom. Else bang. So weird. Right, and then we decide that x, what we do is that we put x's in there. Makes sense. And then we check for, yeah. This is true. Right. Odd x. Man, it's confusing. Right, if x is smaller than 10, then boom, else bang, right? So everything smaller than 10 becomes boom, else, right? Else it doesn't matter. That's why you have to have, because, wait. Why odd? You know what? Let's write this function and we reload. Oh shit. Right, and then we do boom bangs. That didn't do anything, right? Because we need a list. I knew that. I just wanted to double check. We need a list. Oh, right. It only does it for odd... No, wait. Why don't we get any bangs? Oh, right. Right. That was just normal. Yeah, they are smaller than 10. Exactly. Wait, 51 times? Right. If it's smaller than 10, then boom, else bang. But we only do it for odd numbers. We don't do it for even numbers at all. That's what I got confused by. Yeah, even numbers doesn't do anything here. Or, well, it returns an empty list, yeah. It returns an empty list. Right, this should return an empty list, yeah. Right, the last part of the comprehension is the predicate. The function odd returns true on an odd number and false on an even one. Yep. The element is included in the list only if all the predicates evaluate to true. All the predicates. Does that mean that we could do this? We can do... Wait. If we do... another one. Shit. Make this full screen to see the entire thing, right? If we do BB, takes SS as well. Right. No. All right. The reason we have that, I was confused because I was thinking, what's the difference between a predicate and an if statement? But the if statement just decides what we should do, right? The predicate is an exclusionary. Yeah. If the predicate is not true, then we won't do shit. So we can't make an... It's not really an if-else statement. It's only an... It's a predicate, yeah. This has to be true. Not an if-else. It's a predicate. So, alright. I get it. Move your head. Oh shit, my head was in the way. Sorry. Alright, let me show this. There we go. Right, I was thinking of moving the if statement over to a predicate. I had to do that because I didn't understand the difference between if, else, and predicates. But I do now. This just looks a little bit messy when it's a line like this. All right. Yeah, exactly. The element is included only if the predicate evaluates to true. We can include several predicates, and we do that with, yeah, commas. If we wanted all numbers from 10 to 20 that are not 13, 15, or 19, we would do, right, we take all the numbers here in between, and then we say it is not 13, not equal to 15, and not equal to 19. Nice. Can we take a list of predicates? List comprehensions within list comprehensions? Maybe not. Okay. Not only can we have multiple predicates in list comprehensions, an element must satisfy all the predicates to be included in the resulting list. Yeah. We can also draw from several lists. Okay. When drawing from several lists, comprehensions produce all combinations of the given lists and then join them by the output function we supply. This is confusing. A list produced by a comprehension that draws from two lists of length 4 will have a length 16. Colgatino tab says we cannot have comprehensions within comprehensions. Or a list of predicates. A list produced by a comprehension that draws from two lists of length 4 will have a length of 16. Provided we don't filter them. If we have two lists, 2, 5, 10 and 8, 10, 11, and we want to get the products of all the possible combinations of the numbers of these two lists, here is what we do. All right. Okay. Yeah. This is what we do. These are the x's. These are the y's. Right? And we do it for all of them. What order? Right. 16, 2 by 8, 2 by 10, 2 by 11. Yeah, so we start with, we iterate over them. Like that and like that. Yeah, yeah. It's like a nested list, nested loop, kinda. It's equivalent to having a nested loop in imperative programming. As expected, the length of the new list is 9. What if we wanted all possible products that are more than 50? Yeah, we just add this down here. How about a list comprehension that combines a list of adjectives and a list of nouns, or epic hilarity? Okay. Again with the let. Right. Let nouns be hobo, frog, and pope. Let adjectives be lazy, grouchy, and scheming. And then we take an adjective and we add it together with a noun. Right. We take one adjective. Oh yeah, it's one of the adjectives, and one noun is one of all the nouns. Then we get a list of lazy hobo, lazy frog, lazy pope, grouchy hobo, grouchy frog. Yeah, yeah. Epic hilarity. Epic. Yeah. And now let's write our own version of length. Right. We'll call it length. Okay, so the length, it takes a list, yeah. Wait, sum? This got confusion. Why this? Oh, right. That's the length. What is this? All right. The underscore means that we don't care what we'll draw from the list. And oh, right. Yeah, so we take the sum of this entire list and we don't care what the list is. We will just use 1, right? That's what we do. For every item in the list, we will have 1, so we will have... Yeah, we'll have the length of the list when we get the sum, because we will get a list that just says 1, 1, 1, 1, 1 for every item in the list we feed into it. Exactly. Yeah. This... Okay. It doesn't matter. Okay. Yeah. Whatever we draw... Instead of writing a variable name that we'll never use. Alright, so it's just an empty variable. That's the underscore, an empty variable. I think it's the same in Python. Yeah. This function replaces every element of a list with 1 and then sums that up. This means that the resulting sum will be the length of our list, indeed. Just a friendly reminder, because strings are lists, we can use list comprehensions to process and produce strings. Here's a function that takes a string and removes everything except uppercase letters from it. Remove non-uppercase. Alright. It takes a string. Wait, we get the letter. Yeah, we just get the letter. And the letter is every letter from the string and... Wait. Or character. Let's call it character. That's what they do, so let's not call it a letter. Alright, and character is in... I don't remember what element did. Checks if it's in the list, if it's present in the list. And we have another list with A to Z. That's actually way different from doing it in imperative languages. Or the same. It's way different than I've ever done it before, right? It makes sense. It's way easier, kinda. It's way different, so it becomes confusing, but it looks super easy to make this yourself. Yeah, remove non-uppercase. I don't like frogs. I like frogs. Everybody likes frogs, eh? Right, the predicate here does all the work. Indeed, it says that the character will be included in the list only if it's an element of the list A to Z, exactly. Nested list comprehensions are also possible if you're operating on lists that contain lists. A list contains several lists of numbers. Wait. Let's remove all odd numbers without flattening the list. Oh, right. Oh man, this got confusing. All right, so... yeah, here we go. This is a list comprehension within a list comprehension. Yeah, nested list comprehension. There's not a list of predicates, but it is a nested list comprehension, right? So in the list, we take all the even numbers. But in the major list, we take all the lists that are... Yeah. We do it for all the lists within the list. So it's just a nested. But we could exclude, over here, we could add a predicate to exclude lists that are longer than 10, for example. Yeah, if we wanted to exclude this list, I don't know, this looks longer than the other two. So we could exclude this list altogether. Right, so the result would be a list of 2 lists with even numbers. Yeah, yeah. Oh, hello raiding party of XNOPX90. Nice to meet you guys. I hope you had a good stream and a good time. I'm a noob at Haskell and learning Haskell. We're learning list comprehensions. If you know Python, Python has taken this straight off. It's just a Haskellian way of doing it, I guess. Yeah. Right, you can write list comprehensions across several lines. Yeah. So if you're not in GHCI, it's better to split longer list comprehensions across multiple lines, especially if they're nested. Hello, random CyberM. All cool. And XNOPX90 says, we did have a good time until my music crapped out again. Oh, that's unfortunate. Why did the music crap out? Very unfortunate. Alright, but that was list comprehensions. This is something I remember when doing Python, had to go back to this over and over and over again. I actually like this book. It doesn't overstay its welcome, right? And it is pretty straightforward, so I think when you go back to it, it becomes fairly easy to do list comprehensions. Tuples. Okay. In some ways, tuples are like lists. Wait, should we start tuples? Yeah, let's do it. Random CyberM says, by the way, XNOPX90 says, I noticed its checkmark is about after 4 to 5 hours of stream. Oh, you probably... Oh, the music craps out after 4 to 5 hours? Right. In some ways, tuples are like lists. They are a way to store several values into a single value. However, there are a few fundamental differences. A list of numbers is a list of numbers. Wait, are you kidding? A list of numbers is a list of numbers? Thank you, that's super helpful. Random CyberM says, yeah, sorry. Wait, sorry about what? Don't apologize. Well, you do you, but not on my account. Right. That is its type. Oh, right. We're talking about a list of numbers, and we're calling, the thing in itself and what type the thing is. I get it. It looked dumb just as a standalone sentence, but it makes sense in this context, yeah. It is its type, and it doesn't matter if it only has one number in it or infinite amount of numbers. Man, I love the idea of infinite lists. For talking in your chat, but with a different user? Oh, it's completely fine.
Just breathe.
I mean, it's a chat. You can talk about whatever you like. Right. Tuples, however, are used when you know exactly how many values you want to combine, and its type depends on how many components it has and types of the components. These are denoted with parentheses, and their components are separated by commas. Wait, are we stuck with the same type of... Right, if we make a tuple, are we stuck in having numbers as well? Or can I make a tuple of 4 and G? I can. So a tuple, we can have any type of element that we want. Yeah. A list is a list. What you gonna do? Right. That's a big difference, right? Because we cannot make a list like this. Yeah, a list has to have all numbers in Haskell. Big difference. And it has to be a certain length. Yeah. It's a strict list. Yeah. Exactly. You can't modify it after you save it. Indeed. Right. Another key difference is that they don't have to be homogeneous. Unlike a list, a tuple can contain a combination of several types. If I just read this sentence, I didn't have to try it out. Alright. Think about how do we represent a two-dimensional vector in Haskell. One would say... one way would be to use a list. That would kind of work. Yeah. So what if we wanted to put a couple of vectors in a list to represent points of a shape on a two-dimensional plane? Oh no, we're doing mathematics again. Awful. We could do something like a list of lists. Yeah. The problem with that method is that we could also do stuff like... Oh yeah. Wait. Can't we just do a tuple? Wait, does a tuple only, like... Right, if I take 8, 11, and 5. Couldn't I just do that with a tuple as well? Right, which Haskell has no problem with since... Oh, wait. I gotta check this. Are the tuples considered different if they have... Right. Will that not work? Oh, it won't work. Right, since a list has to contain the same amount of type, and a tuple with 3 elements is not the same as a tuple with 2 elements. I get it, yeah. Random CyberM says if you want a dynamic list, you can either use list. Wait, that doesn't look like Haskell, does it? Random CyberM, or a dictionary? Yeah, this sounds like Python. This is Haskell. Yeah, and we haven't gotten to dictionaries yet. Learn you a Haskell, that's where we are. We're reading the book, Learn You a Haskell. Functional programming. Yeah, the list comprehensions. I'm pretty sure that list comprehensions is a Haskell... Haskell thing? Maybe. Nice, my bad once again. I mean, I have this urge when someone apologizes. I just want to tell you not to apologize, but you do you. If you want to apologize, that's fine. But don't... I feel like if you apologize too much, you devalue yourself. That's not good. You shouldn't devalue yourself. You're amazing. Yeah. Oh, I was expecting an apology for the apologizers. That would have been fun as well, but yeah. Alright. Which Haskell has no problem with since it's still a list of lists with numbers, but it kinda doesn't make sense. Yeah, it wouldn't make sense. But a tuple of size 2, also called a pair, it's its own type, which means that a list can't have a couple of pairs in it. And when a tuple of size 3, nice. So let's use that instead. Instead of surrounding the vectors with square brackets, we use parentheses. I mean, so it has... Yeah, that's the functional... what's it called? Right, the whole idea. No... We don't want any side effects. So tuples are very restricted, and that's the point, right? Be restrictive. If you had a language, or if you do things in a way where you can't screw up, then you can't screw up. So that's the goal. I wonder if they've ever heard of Murphy's Law. Random CyberM says, I figured it will trigger you even more. Not my style. Oh. triggered? I mean, it wasn't triggered like feeling bad. It wasn't a bad feeling. It was just, I got that I wanted to be helpful. Yeah. Help that's not asked for, though, is not help, is it? What if we tried to make a shape like, alright. Yeah, we got the error. That's exactly what I tried to do. Exactly what I wanted to do, and I guess this is exactly the error we got. Alright. It is telling us that we tried to use a pair and a triple in the same list, which is not supposed to happen. You also couldn't make a list like... Oh, I thought this was going to be possible, but it's not. So wait, this is how you create a dictionary then in... like, if we're trying to translate into Haskell. This is how we do a dictionary. We make a list of tuples. Right, since they have to be, right? You have to have a string and a number for it to work, right? Like, they showed us that we can't do that, but what we could do is that we make a list of tuples where we take the key value, which is key, and then we have the value, which is 42, of course. And then we have another one here that has the... Right, I wonder if this works. Or if they have to be the same length. Alright. Something like this. Does this work? Yeah, it does work. That would be the equivalent of a Python dictionary, I think. Random Cyber M says, well, it did help me understand you more, so it did help. Indeed it did, right? Yeah. You'd use your own types for dictionaries, says Colgate in on tap. Yeah, this is a hacky way of doing it. I suppose this is a hacky way of doing it, and the further along we get, we would get a better way of doing it, I guess. Nice choices. Thank you, yeah. Right. Because the first element of the list is a pair of numbers, and the second is a pair consisting of a string and a number. Tuples can also be used to represent a wide variety of data. Right. For instance, if we wanted to represent someone's name and age in Haskell, we could use a triple. Yeah. Well, that's even better than a dictionary, right? Wait. No, wait. Oh, shit, I don't remember. Can you have... Dictionary is a pair, right? Key value. You don't have two values with one key. No, you would make your own data structure for that, I guess. Or maybe just use a list. As seen in this example, tuples can also contain lists. They can indeed. So, in one way, lists are more restrictive. And in another way, tuples are more restrictive. They're just different. They're just different. All right. Use tuples when you know in advance how many components some piece of data should have. Exactly. Tuples are much more rigid because each different size of tuple has its own type. Size of tuple, indeed. Right. Right. Have fun, Banana Waffle Monkey. Yeah. Right. So you can't write a general function to append an element to a tuple. You'd have to write a function for appending to a pair. One function for appending to a triple, one function to appending for a tuple. For tuple? What truple? What tuple? I don't know. But you can't really append to a triple, can you? Right? Because... Right, either it is a triple or it's not. Isn't that kind of the point? What did you say again? There was a thing. There's a word for tuples, right? They are non-changeable or whatever. But I guess this whole language is that. Right. While there are singleton lists, there is no such thing as a singleton tuple. Yeah, that wouldn't make sense, yeah. It doesn't really make much sense when you think about it. A simple singleton tuple would just be the value it contains, and as such, it would have no benefit to us. Indeed. Like lists, tuples can be compared with each other if their components can be compared. Only you can't compare two tuples of different sizes, whereas you can compare two lists of different sizes. Two useful functions that operate in pairs are FST. Colgatina says you can define a triple by appending elements to a pair. Oh, right. Yeah. I get it now, yeah. Immutable. There we go. That's because in Haskell, you never change something, right? It's the same with lists or whatever. They are always immutable. Because what you do is you define the triple by adding an element to the pair, but you haven't changed the tuple. No, you have defined and created a triple from the tuple, but the tuple is still the tuple. So yeah, I get it. Thanks, Colgatina. All right. FST takes a pair and returns its first component. First and second. Wait, do we have a third? No third? Just first and second? Wait, can we use... They can be compared... Well, if they can be compared. I wonder how many of the list like the... We can probably do head and tail and all of these things on a tuple as well, couldn't we? Right, if we take 6, 9, 42, and we take head. No? I guess not. Just double checking so I'm not doing it wrong. 6, 9, 42. Right, when we do it with the list, it works. Yeah. Did not work with that tuple. Right, note, these functions operate only on pairs. Alright, first and second only works on pairs. I'm assuming that it's quite common to do 2-item tuples then. Yeah, triples or 4 tuples or 5 tuples are probably rarer. We'll go over extracting data from tuples in different ways a bit later. Okay, we'll get into it later. Colgatina says head needed a list. Indeed, that's what we learned. Cool function that produces a list of pairs is zip. So it produces a list of pairs. It takes 2 lists and then zips them together into one list by joining the matching elements into pairs. Yes. It's a really simple function, but it has loads of uses, especially useful for when you want to combine 2 lists in a way or traverse 2 lists simultaneously. Here's a demonstration. Yeah, exactly. It creates a list of tuples based on the elements. This really looks like a Python dictionary to me. Yeah, it really looks like a Python dictionary. It pairs up the elements and produces a new list. First element goes with the first and the second with the second, etc. Notice because the pairs can have different types in them, zip can take 2 lists that contain different types and zip them up. What happens if the lengths of the lists don't match? Yeah, what happens? Turtle. Oh yeah, it stops with the shortest one. That makes a lot of sense, indeed. The longer list simply gets cut off to match the length of the shorter one, because Haskell is lazy. We can zip finite lists with infinite lists. We can indeed, right? Giving them all numbers, eh? This is redundant though, yeah. Because they already have that, well... Apple 0, 1, 2, 3, we already have that number, don't we? So making a list of these tuples would be a waste. But this is just for... as an example, right? No, more maths. Oh no, more maths. Alright, here's a problem that combines tuples and list comprehensions. Which right triangle that has integers for all sides and all sides equal to or smaller than 10 has a parameter of 24? No, maths. First, let's try generating all triangles with sides equal to or smaller than 10. You know what? This feels like a good spot to have lunch. Yeah. Because I just felt my brain just went to mush. It's like, oh no, not math. Maybe get and start doing maths tomorrow with a fresh mind. Yeah. Yeah. And it's easy to remember where we are with this picture. Because I think... Ooh. We're almost finished with the chapter though. No, I said I wanted not to go too late to lunch today, so... Yeah. Right, so thanks for hanging out today, and yeah, have a good one. Yeah. Cheers.